and welcome to our COMPE 596 project for fall 2021. I'm Chaitanya Patel,
And I'm Abdulaziz Al
and,
Katan.
and we'll be demonstrating you our project via slides. Um, we were given an opportunity to choose from multiple databases. What we decided to go with was Kaggle. Uh, we took in a couple of data sheets and we merged them into one, and we ended up with around 22,000 lines and 22 columns. Our main focus for this experiment is to see what our code could do and what our code could pick up in the form of sentiments, whether they be positive, negative, or neutral. We planned on using 6 different models and differentiated into 2 different methods, as you can see. The first method is the method that we were taught in class, which included decision trees, logistic regression, and random forest. Random forest is a cluster of decision trees, hence it was in that section. The second one is something that we had to do a bit of research for, and that includes the naive bias, the Bernoulli's naive bias, and support vector. Moving on. While we were researching about our experiment, we came across a couple papers that already had done something related to what we were trying to do. We then narrowed it down to 2 different papers that showed similarity with the idea that we had. These two are as follows: the sentiments analyzed using machine learning methods, and the sentiment analysis of Twitter tweets using machine learning approach. Both can be found on IE basis. You can click on the hyperlink to go directly to their paper. Um, what we observed within these 2 papers were they used multiple methods or models that we planned on using. Those models were decision tree, naive Bayes classification, and a support vector machine. What we also found was that none of these had the same database as we were targeting. One of the paper had their own database, whereas the other one created a database on the spot using different methods. Moving on, our problem formulation. So basically, our idea or the thing that we want to test is to see whether a set model can identify the number of positives, negatives, or neutral tweets that we feed in. We then aim to see which of these models show the best accuracy. Now, one would ask, how would you consider whether a said tweet is positive, negative, or neutral? Here are some examples where we show what can be considered as a positive tweet, what can be considered as a negative tweet, and a neutral tweet. Moving on. Um, So as said before, we have 2 different methods, each hosting 3 different models, 6 models in total. The first approach was again the one that we learned in class, which can be seen as decision trees, random forest, and logistic regression. Moving to the next slide, we see naive Bayes classifications, Bernoulli's naive Bayes, and support vector classifiers. Now these ones were the ones that we had to research, and after a while of digging, we found that the first 2 were related to something that we learned in class, which was the Bayes theorem. Sorry, and it helped us. It helped us actually a lot in using them, and as you can see in the following slides. Support vector was something new that we hadn't seen before, and we did see a lot of support vector being used in the papers that we went through. Hence, we decided to use support vector and learn about it a bit. Moving to the next one, our data sheet, as said before, was from Kaggle. We had multiple data sheets. Um, we tried to use multiple data sheets, but then we gathered all the data into one big Excel, which had about 22,000 entries, and each entry had about 22 column worth of data. Some of the columns that we named were the ID, candidate name, what type of sentiment it is, what type of text it is, how many retweets that has got, what was the Twitter ID for it, what was the time for it, and time zone. Not all of these columns were being used in this experiment, but they were there. We then realized that we could not test, validate, and train with the set data that we had. So we decided to use a k-fold method for analyzing the data, and hence we then concluded on using the entire spreadsheet as a training set. Again, we did not use all of the columns, but yeah. I'm moving on to the next slide, and my teammate Aziz will help me with that.
Hi, thank you for that. So moving on to the experimental results and analysis. Here we will see each method and the results and accuracies that it yielded based off of that algorithm. So beginning with decision trees, which is something we learned in class. You can see that when applying the k-fold method, we can see the k-fold cross-validation method, we can see that the cross-validation accuracy is 0.6 and the best validation being 0.61. Moving on to the confusion matrix, we can see that the true values for the 0, 0, 1, 1, and 2, 2 are not high, but decent for the decision trees in this case. And we will see in later methods that we will yield better results using other algorithms. Moving on to our before moving on, I should say that we used multiple ways to evaluate the accuracy of each method to better represent and more accurately represent the accuracy of each method. So we ended up using the k-fold accuracy, the confusion matrix, the accuracy across each fold, which is the main thing we're going to be comparing the algorithms with, and the F1 score using recall accuracy test. So moving on to the F1 score, we can see that the accuracy for a decision tree is 0.61 with a macro and weighted average of 0.6 and 0.61 as well. You can see in the graph here that the accuracy doesn't go very far, and it is capped at 0.615. This is going to be important because when compared to other algorithms, this scaling is going to be different. And yeah, and here we can see the accuracy across each individual fold. Moving on to the next algorithm, we have random forest, which is, as my teammate mentioned, is a cluster of decision trees. So naturally it's going to have a bigger data set to train over and have more accurate and representable results. So right off the get-go, we can see the difference here. And the cross-validation accuracy for the random forest is 0.68, with the best validation being 0.7. And even the confusion matrix is way, way better than that of the decision trees. Moving on to the F1 score, we can see the accuracy of 0.7 and a weighted average of 0.71. For the accuracy across each individual fold, it also fluctuates. And as I mentioned, you can see that the accuracy expands up to 0.705 instead of the 0.615 from the decision trees. So you can see that the folds fluctuate, and at the end they drop off very, very rapidly for accuracy. Moving on to the last method we used in our first method, or last algorithm in our first method, which is logistic regression. And here you can see that the cross-validation accuracy and for logistic regression is 0.69 and the best being 0.7. The confusion matrix here didn't yield as better results than that of the random forest, but it's still a decent confusion matrix. Moving on to the F1 score, we can see it performing better than the random forest of having accuracy of 0.771 and macro and weighted average of 0.71 as well. And when comparing the individual folds, you can see that it fluctuates. It's more consistent, when it comes to rising, and when at the end it decays slowly, not as rapid as the random forest. So that concludes our first method, which had those three algorithms. Moving on to this second method, which includes knife buyers classifiers as the first algorithm used. You can see here that the accuracy for this is almost as close as, slightly better than the decision trees, and it didn't yield any surprising results, or astounding, I should say, results. So we moved on to the Bernoulli bias classifiers, which is another form of the Bayes classifier, and we can see here that the accuracy again did not improve a lot from the previous algorithm, and it definitely did not pass the logistic and random forest algorithms, logistic regression and random forest algorithms. So the accuracy across each fold, again, not a big scaling on the accuracy axis, and it drops off at the end like most of the algorithms so far. Moving on to the last algorithm used in the second method, which is the support vector classifier. And this is the one that we had to research on. We had absolutely no idea how to begin this one, but we ended up figuring it out. So these are the results that it yielded, and they were very satisfactory, I may add. So for the accuracy, the cross validation, the average accuracy was 0.69, and the best one being 0.71. The confusion matrix yielded close results to that of the logistic regression. Random forest still did better than those two. And when it comes to the F1 score, you can see that the accuracy is 0.71 and the macro average is 0.71, which is the same as our highest F1 score, which was a result of our logistic regression. But where it excelled is the weighted average, which is 0.72. And that small improvement will make a huge difference at the end graph, where we compare all the algorithms together. And here you can see the accuracy of each individual fold again. So moving on to the graph I was talking about. Here we compare all the algorithms based off of the accuracy across each fold. And you can see that the top three are the random forest being the light blue one, the support vector classifier being the light green one, and logistic regression being the blue one. We can see at the bottom of our list is decision trees, which is expected since it's not taking as big of a data set as the rest of the algorithms in this application. And for the support vector and logistic regression graphs, you can see that they're pretty close. Logistic regression is more consistently accurate, whereas support vector had a spike where it was better than logistic regression, but overall it was always below the logistic regression module. And at the end, they both fall off, but support vector falls more than logistic regression. So in conclusion, support vector classifier and logistic regression have shown the best accuracy as compared to all the models shown. Like I said, decision trees did not yield good results since it's not taking big data set. But I think ultimately logistic regression was the better between those two algorithms. Thank you for listening to our presentation, and I hope you liked our project and the results that we had to offer. And here are some references that you can check out in your free time.